In this lecture, we're going to briefly talk about covalent bonds. A covalent bond is when electrons are equally shared. One of the best examples is H2. One hydrogen atom brings one electron. The other hydrogen atom brings one electron. And together, those two electrons form one bond. Both of the hydrogens are the same type of atom, and those electrons are going to be equally shared between both. That covalent bond has an optimal distance. This picture here is showing an example of that optimal distance. So you can see on the left that when those two atoms are too close together, that's bad. That's very high energy. And you can see over here on the left in this table, the energy for this first situation where the atoms are too close is very high. When you get to the optimum distance, right, this is our low energy situation over here, and this distance corresponds with our bond length. As the two hydrogen atoms come farther apart, again, we're increasing in energy. The bond energy shown here is that energy needed to break the bond. It's also referred to as the bond association energy. And you can see that the bond association energy for H2 is 105 kilocalories per mole. The bond length down here for H2 is 74 picometers, so you can get an idea of what those numbers are. Now, when you're thinking about this concept, you probably want to use the image of a spring. When a spring is happy, it's just sitting there, right? It's not, being pulled or pushed in any direction. If you push the spring together, it's very high energy, and if you were to let go, it would bounce apart. Okay, so that's the situation on the left where you're just too close together. When you start to pull the spring apart, again, you are going to increase in energy, and eventually at some point you would break the spring, and that would be associated with the bond energy over here. That's pretty much it for covalent bonding for now. We're also going to talk in the future about polar covalent bonds, and that's when you have two atoms that are not the same. So if you have a hydrogen-hydrogen or a carbon-carbon bond, we consider that to be covalent. And then if you have atoms that are different, for example, a hydrogen-oxygen bond, we consider that type of bond to be polar covalent. And we'll get more into that in a little bit. There's also, of course, a type of bond called ionic bonds, and those are bonds where you have unequal sharing of electrons when one atom steals all of the electrons. And we'll get to that in a little bit as well. That wraps up covalent bonding, and we'll do way more with bonding soon.